And very good morning to all. My name is Muhammad AZMIN bin AZAHAR. I'm from Diploma Manufacturing Engineering second year student. Today I want to present to you my diploma project for this semester. My project title are Wash and Dry for Anode Ball WADFAB. My supervisor are Encik Muhammad FAIRUZ DIMIN bin Muhammad AMIN. So without further ado, let's begin the presentation. So for this presentation, they're going to divide it into the 5 parts. So the first one introduction. The second one, literature review, and we continue with the methodology. And the fourth one, result, and last but not least, the conclusion. So the first one, introduction. There are two themes for this semester diploma project. The first one, industrial-based innovation and innovation for sustainability. Continue with our project background. Line plating is a technique to electroplate a thin layer of a protective corrosion resistant metal onto a metallic surface in an efficient manner through the use of repetitive automated machinery that we can see in a factory. But before that, anode ball in that process, anode ball are one of the material that required. So before anode ball that can be sent to the factory, anode ball need to be knit with sand, wash and dry. So continue with our problem statement. We observe that process cleaning anode ball are very difficult and taking a long time. In addition, there are very limited product in market that solely purpose for this green mechanical anode ball cleaning. Report. In this chapter, history of anode ball, market survey, commercial value, technology, and pattern of the past will be the main discussion. We start with 2.2. Electroplating was invented in 1805 by Italian inventor Luigi Butanelli. He did this by linking a wire between a dissolved gold solution and a battery known as voltaic pile. Nowadays, process of electroplating requires anode ball. Plating has been practiced for hundreds of years and is still necessary in modern technology. So, when the anode ball is mixed with sand, it needs to be separated and cleaned before it can go to the line plating in the factory. 2.3 Anode ball cleaning machine. Anode ball cleaning machine is a product that can facilitate and shorten the process of washing it after the anode ball is rotated alongside the sand. Firstly, a sand-filled anode ball is placed in a water-filled barrel. The anode ball will be separated from the sand by rotating the barrel equipped with brush. Finally, the water will be secreted from the anode ball that has been transferred into the basket by turning the basket. 2.4 Market survey. Market survey in this project is being done by using the Google form. There are 22 respondents participate in the survey. There are two sections in the survey, which is section A and section B. The reason why there are no survey being done on the Shopee or any e-commerce are because this kind of product are very limited and hard to find in the market. 2.5 Commercial value. Based on the survey and initials being done, cost of the product are between 100 and to 120 ringgit. This estimation is based on our initial design, as we can find any price of the product that related to this project. As stated earlier, there are very few products that really related to our project. Early design and pattern that can be related to our product can be traced from H.E. Lauren from July 6, 1935. The first one, device for cleaning an electroplating ball. The invention, creating a device that cleaning metal ball by energy action and subsequently electroplating them in one operation. Second one, system and method for rough cleaning and anode assembly. The product are about 3 rough cleaning station and overhead conveyor are used in an anode rough cleaning system to carry discarded anode assemblies subsequently through 3 stations. So for the chapter 3 methodology, to make it easier and more understanding, we make it in the flowchart. So you can see the process that we take in order to complete the product and present the product. These are the result of the survey. Section A. Continue on, we start our concept design sketch. There are three concept design. The first one, design A, which is we try to make it simpler and easier to operate. So the second one, design B, we focus on how to is the handling, make it handling much better. So we decide to add a belting that can be controlled by the hand crank. So design C, which is have the most feature, we make the cleaning can be open and locked equipped with the net. And also important to note that this design also have the highest cost because it has a wide range of functionality compared to design A and design B. So in order to select the design, we opted to run the concept screening and scoring. It helps selection of the product much fair and easier. From the design that we produce, scores show in this one that the C design is with the highest mark. So these are detailed drawing. So the first part is the upper body part. Anode ball will be put here first after going through a mixed process with the sand. It's equipped with a drain plug to remove all the water after cleaning process. It also have a door that function to remove the anode ball direct to below basket. And it also have equipped with a net so that it action as a filtration. And the second one is below body part. It's for a drying process, and we opted to use a absorb heat material so it will help the drying process faster. And the third one is the lab part. We opted to use the material from the steel as it gives much more legibility and suitable for industrial use. And the fourth one is a hand crank, function as a power source that rotate the upper and below container, equipped with a bell. As I stated earlier, both of the container and the basket will be rotated. And the last one is the high quality wheel. So 4.6 material selection is a vital process at the end organized procedure that allow us to reject inappropriate material. Therefore, we come up with a solution for the upper body and below body part. We will be using either plastic or material. The main reason is because there are a lot material from plastic or metal that we can choose from. In the left side, you can see the table that summarizes our specification and the reason for it. For example, the strength, because the upper body part need to withstand a vibration and rotation that produced by a hand crank. After that, we start with the concept screening and scoring into the selection of the material. We start with the first table, which is metal and plastic. And we continue with the upper body part, which is between HDPE and PVC. And below body part, between polycarbonate and polypropylene. And for the lab part, we opted to use metal because it's much more suitable for industrial use. Our final product. We continue with product analysis. Product analysis are about mechanism of the product on how it works. So our product will start with a sand fill anode ball is placed in a water filled container. And after that, the anode ball will be separated from the sand by rotating the barrier using the hand crank in the left side. And the upper container also equipped with a brush to clear the sand from the anode ball. The anode ball will be placed in the basket under the barrier for drying after it has been cleaned. Finally, the water will be excreted to the drain plug and anode ball from the upper container that has been cleaned will transfer into the below basket through the door. And last but not least, both container are equipped with a lock so that the anode ball will not going out while the product is operated. So the next slides are about the manufacturing process and fabrication of anode ball cleaning machine. There are a lot of manufacturing process that involve into the fabrication of our product. One of it are welding process to connect the leg with the base, and also for my steel that connected the drum to the legs. The reason why we use the mild steel rather than stainless steel as planned because we can't get the material as it was too expensive, and we decide to reduce the cost. Secondly, drilling process into the container to equip with a lock, hinge, and a drum plug. We are also using the rivet for locking the drum container door. Next one, grinding process of the drum container, the leg, and the raw material. And picture below are some of our manufacturing that we get to capture. Limitation and sensitivity. We need to realize that how limited our experience in designing a product. Hence, there are some compromise that we made into design, considering a lot of factors. Firstly, we tend not to be depending on to equip the product with the power source. Why we opted to doing so is because we want it to be sustainability as uh our team also, and also we doesn't want it to release any harm to our environment. Secondly, the size of our product are quite big. Because of the bigger size, we can quite find the right basket for the drying process. So we opted to use the same drum container, just like upper body pipe with a modification. And thirdly, the weight of the product. It is because our product is equipped with a lot of material, and it can cause a significant weight. From, for example, from the legs and from the drum container. And because of it, we can't quite find the right wheel, as both container are quite heavy. For the cost analysis, the total costs are around RM285 and we decide to sell it around RM310. Considering our target are for industrial use, we think the price are quite affordable. So in order to measure a profit, we use a return of investment formula. As you can see, the return of investment are around 9.6%. So according to statistics, 7% ROI is a good. So from the calculation, we believe the price of the product is suitable and we can still make a profit from it. So the final one, conclusion. From our observation, our objective to create a product that can help in cleaning and drying process of anode ball are successful. Secondly, with the help of analysis and research on past design, really help influence our conceptual design. And the third one, concept screening and scoring help us to develop the product because it can show the impacts on its quality, cost, and desirability of the final product. So there are a lot of things we have learned by just involved in the process creating this product. We learn a lot of things from just involved in the fabrication process. Lastly, we want to thank everyone that involved, especially to our SV, Dr. FAIRUZ, Encik Azali and Dr. Edrozi for existing and help us throughout development of our product. Lastly, we want to say thank you and Assalamualaikum.